Hey everyone, so after learning the basics of trigonometry, now you want to challenge yourself to solve word problems. In this tutorial, I'm going to go through some of the keywords, give you some tips, tricks on how to make that process a little bit easier for you. Now, if this is too advanced for you and you want to maybe learn the basics, click on the link up here to watch the first part of this tutorial. Otherwise, keep watching this video. Let's do some challenging word problems to help you become a better mathematician. My name is Peter. Grab your calculator and let's get started. As mentioned earlier, this video is going to be about applications of trigonometry. We're going to solve real-world problems using trigonometry. All of these problems are going to have the shape of a right triangle, a hypotenuse, an adjacent side, an opposite, and a 90-degree angle. Here's some tips to help you solve word problems involving trigonometry. Number 1, draw a diagram. Number 2, identify the trig function that fits the diagram. And then number 3, solve the equation and include the units of measurement in the final answer. Before we start looking at examples, let's go through two important key terms that appear in word problems involving trigonometry. The first key term is angle of elevation and the second one is angle of depression. Angle of elevation is the angle that is formed when you move your sight line from a horizontal line and you go upwards until you see the object. So if you want to look at the sun, you would be forming an angle of elevation because you're going to be looking upwards. The angle of depression is the opposite of the angle of elevation. If you want to look at something that is down, you would have to move your sight line from a horizontal line and then go downwards until you see your object. If a fisherman wants to look at a fish that's inside the water, they would move their sight line from horizontal position downwards until they see the fish inside the water. The first question that we're going to look at says a ladder that is 20 feet long is leaning against the side of a building. If the angle formed between the ladder and the ground is 75 degrees, how far is the bottom of the ladder from the base of the building? The first thing that we need to do is to draw a diagram. So I'm going to draw the wall and the ground, and then the ladder is going to be this diagonal line that is going to be labeled 20 feet. The next thing that we're told in the question is the angle that is formed between the ladder and the ground, and that angle is 75 degrees. So let's go ahead and label that angle there 75 degrees. The final thing is to label the distance. How far is the bottom of the ladder from the base of the building? So that distance is going to be this horizontal line from the wall to the bottom part of the ladder. After drawing this diagram, now we need to identify which of the three trig functions are we going to use. In this diagram, we're given the hypotenuse. So I know that I'm not going to use tangent because in the tangent, there's no hypotenuse. However, in sine and cosine, there is hypotenuse. The way we narrow down is by looking at where x is and the angle. X is right next to the angle, so I know that I need to use cosine. So let's go ahead and find the cosine of 75 degrees, and it's going to be equal to adjacent, which is x, divided by the hypotenuse, 20. If you want to solve this equation here, you need to cross multiply 20 so that x is alone. So when you multiply 20 on both sides, you're going to have 20 times cosine of 75 is equal to x. When you multiply 20 times cosine of 75, you're going to get 5.176 feet, which is our x value. The second example that we're going to look at says Kelly is flying a kite to which the angle of elevation is 70 degrees. The string on the kite is 65 meters long. How far is the kite above the ground? The first thing that we're going to do is draw a diagram. The second example we're going to look at says Kelly is flying a kite to which the angle of elevation is 70 degrees. The string on the kite is 65 meters long. How far is the kite above the ground? The first thing that we're going to do is to draw a diagram. I'm going to draw a string that indicates where the kite is while it's in the air. And then the second thing I'm going to do is I'm going to show the horizontal distance on the ground. The third thing I'm going to do is indicate the angle that we're given here, 70 degrees, the angle of elevation. And then the other thing I'm going to do is to show the distance of that string. It's 65 meters long. Finally, the question asks, how far is the kite above the ground? So I'm going to draw a vertical line here that indicates that this is going to be 90 degrees. and that is going to be our x, that vertical distance. Now we need to figure out which of the three trig functions we're going to use. In this diagram, we're given the hypotenuse. That means I'm not going to use tangent. I have to either use sine or cosine. I go back to my diagram and I see the distance I'm looking for is across. It is opposite the angle that's given. That means I need to use the sine function. So I'm going to go ahead and find the sine of 70 degrees, and that's going to be equal to the opposite, which is x, divided by 65. If I want to find x, I need to cross multiply 65. When you cross multiply 65 on both sides, you're going to have 65 times sine of 70 is equal to x. Using your calculator, the final answer is going to be 61.08 meters is equal to x. This is how high the kite is above the ground. The third example we're going to look at says a ladder leans against a building. The top of the ladder reaches a point on the building which is 18 feet above the ground. The foot of the ladder is 7 feet from the building. Find the measure of the angle which the ladder makes with the level ground. The first thing we always do is to draw a diagram. So I'm going to draw a diagram of the building, and then I'm going to label it 18 feet according to the information that we're given. The next thing I'm going to do is to indicate where the ladder is. So the ladder is leaning against the building, and we're told that it's 7 feet. The bottom part is 7 feet from the building. So the final part is to figure out the angle that is formed by the ladder and the level ground, and that's going to be this angle here. We're going to label it theta. So now we need to know which of the three trig functions do we need to use. From this diagram, there's no hypotenuse. We're not looking for the hypotenuse. We're looking for the angle. So that means I'm not going to use sine. I'm not going to use cosine. I'm going to use tangent because I am given an opposite side and an adjacent side. So let's go ahead and find the tangent of theta, and this is going to be equal to the opposite, which is 18, divided by the adjacent, which is 7. When you divide those two numbers, you get 2.571. If you want to know what the angle is, we need to find the inverse of tangent. So theta is equal to tangent inverse of 2.571, and theta is going to be 68.749 degrees. So the final example says that in order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet straight up a road which leads to the top. Find the number of degrees contained in the angle which the road makes with the horizontal. First step, as always, draw a diagram. So I'm going to draw a diagram of a hill, and that hill is 250 feet high. And then the next thing I'm going to label this hill with is that distance of the road. So that's 2,000 feet long. And then finally, I'm going to indicate on this diagram where the angle which is formed by the road and the horizontal. And that angle is going to be down here, and I'm going to label it with theta. So I go to my three functions here, and I look for the function that has a hypotenuse, just like this hill here. The hypotenuse is 2,000 feet. So that means I'm not going to use tangent. I'm either going to use sine or cosine. So I look at 250 and I notice that 250 is opposite the angle that I'm given. That means I'm going to use the sine function. So I'm going to calculate the sine of theta is equal to 250, which is the opposite, divided by 2,000 feet, which is the hypotenuse. When you divide those two numbers, you're going to get 0.125. So if I want to figure out what my angle is going to be here, I need to find the sine inverse of 0.125. So let's write that. Sine inverse of 0.125. Using your calculator, the angle is going to be 7.18 degrees. All right, here's the pro tip. First thing that you need to do before you start solving a word problem, draw a diagram. Second thing, identify the trig function that corresponds to the diagram that you drew. And then the third part is just to solve the equation. After working on several examples, here are 2 exercises for you to try on your own. Make sure you look for keywords such as elevation and depression, and then also draw a diagram before you start any calculations. Finally, all the answers to these 2 exercises can be found in the description below. Good luck!